Have you ever just wished you had an AI assistant that could handle all the annoying parts of your digital life? One that connects to your email, your calendar, your company's database, and just gets things done for you? Well, that future is a lot closer than you might think, but there's been a hidden problem, a bottleneck that's been holding these super smart AI agents back. Today, we're going to look at the incredibly elegant solution that finally unlocks their true power. Okay, so let's set the stage. The groundwork for these AI super agents is already in place. We have this universal standard that lets AIs plug into a massive ecosystem of tools. With just one command, your agent could pull a sales report, draft an email about it, schedule the follow-up meeting, and log the whole thing. It's this promise of a totally seamless workflow that could save us literally hours of busy work. Sounds amazing, right? Almost too good to be true. And yeah, that's kind of because there's a catch. What do you think happens when you give an assistant access to 1,000 different tools? Or 10,000? Well, it turns out that being too helpful has a hidden cost, a big one, that can grind these powerful agents to a complete halt.
So to really get why this is happening, we first have to peek inside the agent's toolkit. We need to understand the tech that makes this whole universe of tools possible in the first place.
It all comes down to something called MCP, the Model Context Protocol. The easiest way to think about it is like a universal travel adapter, but for AI. Instead of building a custom plug for every single app, developers can just use MCP one time, and boom, that single connection unlocks an entire world of tools for the AI to use. It's the reason we can even have this conversation, but it's also, weirdly enough, the source of our big problem.
And this is where the story takes a turn. As developers started hooking up more and more tools using MCP, they noticed something troubling. The more tools an agent had, the slower it got, the more expensive it was to run, and the less efficient it became. The very thing designed to make them powerful was actually bogging them down. The problem boils down to what we can call the two token traps. Just imagine the AI's working memory, its context window, is a really, really small desk. First, before the AI can use any tool, it has to read the entire instruction manual for it. So with thousands of tools, it's like piling thousands of manuals onto that tiny desk before you even start working. That's the first trap. The second trap? After using a tool, the AI writes out a full memo of exactly what it did and what the result was, adding even more paper to that cluttered desk. This old method is what's known as direct tool calls. It's where the AI model has to read all those manuals up front. Then it calls tool A, waits for the result, reads that entire result, and then, based on that, decides to call tool B. It's basically acting like a micromanager who has to read and approve every single tiny step of a project. Let's make this real. Say you ask the agent, hey, grab my meeting transcript from Google Drive and add it to Salesforce. So, step 1, it calls Google Drive. Step 2, the entire transcript gets loaded into its memory, piling more paper on that desk. Then step 3, it calls Salesforce and has to pass that whole transcript along again. It's just an incredibly inefficient, repetitive process that burns through time and money. So clearly, this old way just isn't going to cut it. We need something better. And the solution, well, it's as elegant as it is powerful. Instead of making the AI act like a chatty micromanager, what if we let it be an efficient programmer? This is the breakthrough. This is the big idea. Instead of telling each tool what to do, one by one, the AI agent just writes a short, simple piece of code. A script that tells all the tools how to work together to get the whole job done in one shot. The agent doesn't have to watch every step, it just writes the plan and lets the code run. And you can see the difference right here. It's night and day. On the left, you've got those slow, chatty back and forth calls. But on the right, the agent just writes 2 simple lines of code. Get the document, store it. Then tell Salesforce to use what you just stored. The crucial part is the AI itself never has to read the transcript. The data flows directly between the tools, with the code just guiding it along. Now, this simple shift from prompting to programming does way more than just make the agent faster. It unlocks a whole new set of abilities. You could honestly call them superpowers. So how much more efficient are we really talking about? For that same task, moving a meeting transcript from Google Drive to Salesforce, switching to code mode reduced the number of tokens the model had to process by, get this, a staggering 98.7%. That isn't just a small tweak, that's a total game changer for speed and cost. And this chart really puts it into perspective. Look at that. The old way used a massive 150,000 tokens. With code, it's just 2,000. All that paper we imagined cluttering up the AI's tiny desk, it's gone, wiped clean. And now it can think faster, work cheaper, and honestly start tackling much, much bigger problems. So what are these superpowers? Well, first, it gets selective memory. It's not reading a whole library anymore, just the one book it needs for the job. Second, data filtering, so it can chew through huge files and just pull out the key summary you actually care about. Third, and this is a big one, privacy shields, which let it handle sensitive data without ever seeing it. It also gets smarter logic to work more on its own, and state persistence so it can save its work for later. Basically, it learns.
And that privacy point is absolutely critical. With this code-based approach, the agent can be told to update a customer record with a real email and phone number. But the model itself, it only ever sees placeholders, these generic tokens. The actual sensitive info flows directly and securely between the tools, never even entering the model's brain. This is a massive leap forward for being able to trust AI agents with our most important data. So let's pull back. What does this all really mean for the future of AI? Well, this shift fundamentally changes how these agents are going to work. We are moving from being prompters who just tell them what to do to working with programmers who can write the solutions themselves. Now, I gotta be clear, this isn't some magic bullet that solves everything. Giving an AI the power to write and run its own code means you need a really secure, sandboxed environment for it to happen in. And that adds a layer of engineering complexity that those simple, direct tool calls just don't have. It's a classic trade-off. You get all this incredible power and efficiency, but it comes with the responsibility of managing it all safely. But this whole thing leads us to a really fascinating final thought. We started this by talking about an AI that can use tools. But with this new code execution ability, an agent can combine tools in new ways and then save that code, basically building its own new tools over time. So the real question isn't just what an agent can do for us anymore. The question is, when an AI can build its own toolkit, what kind of problems are we even going to ask it to solve?